welcome back for our continuation of 8.3. So yesterday we talked about all the pieces to these rational functions. We learned all of the vocabulary. Now we're going to take some time and we're going to work on how to combine all this vocabulary together to actually graph these. So just make sure you have a reference. So yesterday we talked about points of discontinuity. You factor and set the denominator equal to 0. For the x-intercept, you factor and set the numerator equal to 0. For the y-intercept, you plug 0 in for x to find y. The horizontal asymptotes, you compare the degree of the numerator to the degree of the denominator. So again, that's just a review of the pieces to all of these things, because now we're going to put those pieces together. So, talking about graphing these rational functions. So the first thing we need to do is factor everything. All right? So I am going to move this over so I can factor this. So on top, I'm getting x plus 4, x minus 3. Then the bottom is a difference of squares. X plus 2, oh, sorry. X plus 2, x minus 2. Now again, if you're struggling with factoring, please make sure you come in and get some help, because factoring is just a baby step to everything we need to be able to do in this chapter. So that's what it looks like factored. So now let's find the points of discontinuity. So my point of discontinuity, that's going to happen when the bottom equals 0. So the first thing I'm going to do is set the bottom equal to 0. So I have 2 points of discontinuity, at -2 and at +2. Notice, neither one of those points of discontinuity factor out. So what that means, because they don't factor out, that means both of them create a vertical asymptote. So I'm going to have a vertical asymptote at x equals 2 and x equals -2. That's what that's telling me. Now, let's continue on to find the x-intercept. Again, the x-intercepts are where I set the numerator equal to 0. So I set those pieces of the numerator equal to 0. So I get an intercept at -4, 0 and an intercept at 3, 0. So -4, 0 puts me right here. 3, 0 right there. So I'm going to put those on my graph as well. And it also wants the y-intercept. So the y-intercept, that comes from plugging 0 in for x. So when I plug 0 in for x, I'm getting 4 and -3 to -2 as I'm plugging in 0 to that factored form. So I get -12 over -4, or I'm getting a y-intercept up at 0, 3. All right, one last piece that we need to look at. The horizontal asymptote. Remember, the horizontal asymptote comes from comparing the degree on the top to the degree of the bottom. Here is that same over same case. That same over same. Remember, that means you take the ratio of their leading coefficients. So that means, I'm sorry, I'll write that a little bit better. That means we have a y-intercept, or a horizontal asymptote at y equals 1. So I'm going to plot that as well. A y equals 1 is a horizontal asymptote. So I have all of my pieces now. Now, the redeeming feature of this, now that I have the asymptotes and those points, now I get to use a calculator to calculate the rest of it. All right? So you can whip out your calculator at this point, and we are going to graph this using the calculator to kind of fill in the rest of the graph. On the test, I need to see all of your work for all of that portion, and then you may use the calculator from there. So let me clear out all of that. All right, now when you're typing these into the calculator, it is of extreme importance that you use parentheses around the numerator. So x squared plus x minus 12. Use parentheses around the numerator and parentheses around the denominator. Oh, there we go. Don't know what happened there. So this one has to go as well. So that's what it should look like. Okay, you go back, you're graphing the original one, putting parentheses around the numerator, parentheses around the denominator. Now let's take a look at what this looks like. So there's our general shape. Now all of our points and all of our asymptotes lead to this graph. But what I'm allowing you to do is I'm allowing you to use this calculator. So you can now go back and say, hey, I know where this is. A piece of it is here. A piece of it is there. The other piece of it is there. So once you do all the calculations, use the calculator to finish it off and actually plot the curve. All right, so let's do another example together. So again, the first thing is we need to factor the numerator and the denominator. So this is going to turn into x plus 3 over, and that is going to be x minus 5, x minus 1. All right, and the first thing, we want to know those points of discontinuity. So I'm going to take that denominator and set each piece equal to 0. So we get a point of discontinuity at 5 and at 1. Now I want you to notice that when you do this, neither one of those cancel out. So that means both of these are creating vertical asymptotes. So I'm getting a vertical asymptote at 1 and at 5. All right. Next, I'm going to find my x-intercepts. And again, x-intercepts is where you set the numerator equal to 0. So I'm getting an x-intercept at -3, 0. So -3, 0 puts me right there. Finding the y-intercept. All right, well, y-intercept, remember, that's where we plug 0 in for x. So I'm getting a 3 on top, then 5 and -1 on the bottom. So we're getting -3/5 for the y-intercept. So -3/5 Well, that's going to be somewhere about right there. All right. Now we have to analyze the degree. So the degree here, we have 1 over 2. So that's less over more. So our asymptote is at y equals 0. All right. So now we're going to use a calculator from here. We're going to take our calculator, clear out the one we just had, and type in our new one. Again, make sure you use parentheses around the numerator and around the denominator. All right, and now we're going to graph this. All right. So let's take a look at what's happening here. So we have our graph going like this. Then the bottom goes like that. And our other side goes like that. And I apologize, I actually realized way back here I made a mistake. That should be a -5 there. So this point here should actually be up at positive 3/5, not at the -1 like I had put down here. So I apologize for that mistake. Now the cool thing is when you look at the graph, sometimes you'll see you've made mistakes like that, and it gives you an opportunity to go back and fix those mistakes. But again, the goal is find each of those points, then use the calculator to fill in the rest. So let's do our last example now. So first, we need to factor the numerator and the denominator. So I'm getting x minus 2, x plus 1 on top, and on the bottom, x minus 2 and x plus 5. All right, so what makes the denominator equal to 0? So x equals 2, we're getting a point of discontinuity. And at x equals -5, we're getting a point of discontinuity. Now, what I want you to realize is look at that cancels. So here, we are getting a whole, and here we're getting a vertical asymptote. All right, now, at the moment, I don't know exactly where that hole is. I know that it's wherever x equals 2, but I don't know where the graph is going to be around x equaling 2. So the only thing I can do, I have to wait on putting that hole in there. One thing I can put right now is my vertical asymptote. Okay, I'll get back to that hole at the end. X-intercepts, setting the numerator equal to 0. All right, now we have to be careful though, because again, we can't actually use the x minus 2 equaling 0 because we've already ruled that out. It canceled out. So we only use the one we have left. We only use that -1, 0. Again, we can't use the x minus 2 because it canceled out. Y-intercept, same thing. I can plug in 0 for x, but again, I only have to worry about the piece that's left, not those -2, the x minus 2's. So I get a y-intercept of 1/5. And I want to compare my degrees. So we have same over same. So we're going to have a y-intercept at the ratio of the leading coefficients, which is just at 1. All right, so now I've done every piece that I can, all right? Now it's time for me to use a calculator to graph these. So I pull out my calculator. Now when you're graphing it, because we're graphing in general, use the original form, okay? So use the full x squared minus x minus 2. Oh, divided by, parentheses again, x squared plus 3x minus 10. And let's see what this looks like. And this one, we get something unique, something looking like this. So let's quick sketch that. So again, let's take a look. The upper piece looks like that. This lower piece looks like that. Now, about that hole, okay, remember we have a hole at x equals 2. So what I'm going to do to indicate that, wherever I put my graph, I'm going to put a little empty circle there. All right, that little empty circle is going to represent the fact that the function exists everywhere around that point, but then that point only doesn't exist in the graph because of that discontinuity. So it's difficult to see because the graphing calculator doesn't really show it very well. But do realize that point is not actually there. That point is missing because of the point of discontinuity. All right, so we have made it through these notes. Again, a lot of stuff going on here. The neat thing though is all of it you learned yesterday, and now you're just using the calculator to kind of fill in the rest. But do make sure you have all of this written down, and then please come back to class tomorrow prepared to do your practice work.